Another rule that we use for finding the derivative is the quotient rule. So the quotient rule we use when we have fractions. So two functions, one on the top, one on the bottom. And here is what it looks like. Now this one can be a little bit trickier to remember, and the order of this one does matter. Okay, so what we have is we have the bottom times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. Okay, so the order here matters because of the subtraction. So if you flip-flop the top and you put the top times the derivative of the bottom first, your answer will be wrong because it won't have been in the right order. So unlike the product rule where the order does not matter, in the quotient rule, the order does matter. Okay, so there's like a little saying or whatever that can also help you with this. So it's low d high minus high d low, square the bottom, and away you go. So again, low means like the bottom. So it's the bottom times the derivative of the top. So low d high, d meaning like the derivative. So low d high minus high d low, square the bottom, and away we go. So hopefully that gets stuck in your head, and you're welcome. So low d high minus high d low, square the bottom, and away we go. So we're going to apply that over here. So we want to find y prime. So we're finding the derivative of this. So we're going to plug this into our quotient rule. So we've got the bottom, so x cubed plus 6 times the derivative of the top. So the top would be 2x plus 1 minus the top, so x squared plus x minus 2, times the derivative of the bottom, which would be 3x squared, all over the bottom squared. So for the most part, you're just going to leave the bottom as is. You don't have to like FOIL the bottom or expand anything there. The top is what you want to expand and FOIL out and simplify a little bit. Okay, so again, using that quotient rule, we've got low d high minus high d low, square the bottom, and away we go. So let's actually simplify this a little bit. So we're going to FOIL out the top. So we're going to get 2x to the fourth plus x to the third plus 12x plus 6. And then when we're here, we don't want to forget the negative. So I'll just do this in 2 steps so we're good. So the negative, and then I'll distribute the 3x squared. So 3x to the fourth plus 3x to the third minus 6x squared. Whoops, all over x cubed plus 6 squared. So we want to make sure that we don't forget to distribute that negative, since we're subtracting that, to every piece. Okay? And that is why the order matters, because if you had it flip-flopped, you would be subtracting the wrong equation and everything gets all messy. So if I distribute that in, and then I'm just going to kind of do this in one step, but so I have 2x to the fourth minus 3x to the fourth, so I'm going to have negative x to the fourth, and then I have x cubed minus 3x cubed, so I'm going to have negative 2x cubed, and then I have no x squared over here, but I have a negative 6x squared, so that becomes positive 6x squared. Then I have 12x minus nothing, so plus 12x, and then 6 minus nothing, so plus 6. All over this x cubed plus 6 squared. Okay, and here is our derivative using the quotient rule. So here we want to find an equation of the tangent line to the curve y equals 2x over x squared plus 1 at the point 1, 1. So remember, whenever they're asking for the equation of the tangent line, our first step is to find the slope of the tangent line. And the slope of the tangent line is just the derivative at a particular point. Okay, so hand in hand goes slope and derivative. So slope of tangent and derivative mean the same thing. So the first thing we have to do is find the derivative at this point. So we're going to find y prime. And we have a quotient here. So we're going to use the quotient rule. So we're going to do the bottom, x squared plus 1, times the derivative of the top, which is 2, minus the top, which is 2x, times the derivative of the bottom, which is 2x, over the bottom, so x squared plus 1 squared. Okay, so I'm going to multiply the 2 on the top here, so I have 2x squared plus 2, and then I have, this is going to be negative 4x squared over x squared plus 1 squared. So we can kind of combine these together a little bit. So y prime is going to be negative 2x squared plus 2 over x squared plus 1 squared. So that's our derivative function, which is like the slope function for the tangent line, but we want to find the actual slope, so we want the number when it's at this point 1, 1. So we're just going to plug in the x value of 1 in for x. So I'm just going to say y prime at 1. So we're going to get negative 2 times 1 squared plus 2 over, this is going to give us 1 squared plus 1 squared. So when we do this, we end up with 0 over 4, which is just 0. So the slope of this line is 0. So we're going to use that point and the slope in point slope form. So y minus 1 is equal to the slope, which is 0, x minus 1. So if I solve this, I end up getting y equals 1. So my tangent line equation would be y equals 1. Now here's a special note just to think about, is that you don't always have to use the quotient rule every single time you see a quotient. So sometimes it's easier to rewrite a quotient first to put it in a form that is simpler for the purpose of differentiation. So the example that we have here, we could use the quotient rule. Is it bad to use the quotient rule? No. The quotient rule is a little bit annoying sometimes because you have to make sure you have it in the right order and you have more math to do. But if you can rewrite it so you can use the power rule instead, just like how we did with the product rule, if you can kind of rework it and use the power rule, you can. So in this example, I could rewrite this x as like x to the negative 1 on the top, and I can multiply it in so that I end up with something like this, right? So I went from having a quotient to not having a quotient anymore, and I've changed it into something that I can use the power rule for. So double check first when you see something, is it something that you can rewrite it so you can use the power rule? If not, use the quotient rule. If you're not sure, you can use the quotient rule and just always use that when you see a quotient so you don't have to worry about it. So the last thing we're just going to look at is this table of differentiation formulas. These are things that we talked about already, but it's kind of summed up nicely. So if you wanted to, write this out somewhere, basically right, the derivative of a constant is 0. If you have a constant times a function and you're taking the derivative, it's just the constant on the outside times the derivative. When you're doing addition, where's my addition? Addition or subtraction here, you just take the derivative of each piece and add them and subtract them. When you have a power, you use the power rule. Derivative of e to the x is e to the x. And then these bottom two are our product and quotient rules, and they're written out with the correct formula for them. So that's a good reference guide to look at. And then the last thing that we're going to look at, okay, is just kind of more just making sure we understand what we're using and how we're using it. So here we have information. F of 3 is equal to 4, g of 3 is equal to 2, f prime of 3 is 6, and g prime of 3 is 5. And we want to find the following numbers. So if we go back to our differentiation rules, when we have addition, the way we can figure out addition, and I'm just going to go back to here for a minute using this. Okay, when we're adding, we can take the derivative of each piece and add them together. So what I really would be doing here would be f prime of 3 plus g prime of 3. So f prime of 3 they said was 6 plus g prime of 3, which is 5. So we end up with 11. For b, we're doing multiplication. So it's using the product rule. So it's f times g. So we have to use that product rule. So it's going to be the first, which is just f of 3, times the derivative of the second, so g prime of 3, plus the second, so g of 3, times the derivative of the first, which would be f prime of 3. So f of 3 is 4 times g prime of 3, which is 5, plus g of 3, which is 2, plus f prime of 3, which is not plus, times, which is 6. So we end up getting 20 plus 12, so we get 32. Okay, and for C, we're doing division, so it's the quotient rule. So we're going to have the bottom, so g of 3, times the derivative of the top, I'll just write it like that, f prime of 3, minus the top, so f of 3, times the derivative of the bottom, all over the bottom squared, so g of 3 squared. So if we plug this stuff in, we have g of 3, so we have 6 times, g of 3 is 2, so 2 times f prime of 3, which is 6, minus f of 3, which is 4, times g prime of 3, which is 5, all over g of 3, which is 2 squared, so 4. So we get 12 minus 20 over 4. So we get negative 8 over 4, which is negative 2.